Brains are fun. Yeah, I don't care. We're doing. All right. Yo. Did I update this? I sure did. Kind of. I didn't update the memes. It's gonna just stay for a little while. It's my spirit cat. But today, I'm gonna do some proportions. I'm gonna do some linear equations. We're doing proportions because it's kind of my last little hurrah of fractions. So we'll also do some reviewing. You recall converting back and forth from improper fractions and mixed fractions. In order to go from improper to mixed, you divide the numerator by the denominator and take note of any remainder. So 13 over 7, 7 goes in there once, there would be 6 left over. So you say, okay, that's 1, and the 6 that's left over out of 7. Vice versa, if you tried to convert that back to an improper fraction, you take that integer number hanging out front, the 1, you multiply that sucker by the denominator, so the 7. You have 1 times 7 and add it to the 6 that's already hanging out on top, and you're back to having 13 over 7. You feeling good? Feeling good? Yeah, feeling good. All right, everybody's excited. And as I stressed last time, mixed fractions don't work well with you doing the usual type of math because a mixed fraction is basically 2 numbers being added. So whenever you're doing math with them, you usually have to convert it to an improper fraction, do the math stuff, and then convert it back to a mixed fraction, if it matters to. If you end up with like 5/8 or something like that, then it's like, okay, you're already a proper fraction. We're happy, good enough. Let's do a bunch of problems. I wrote these from the heart. The Spider-Man ate 1 5/6 pounds of cat food last week. This week, he ate 3/4 pounds less. How much cat food did Spider-Man eat this week? I enjoyed writing that. Let's see. Start us off. We got 1 5/6, and this week he had 3/4 less. Always fond of my Spider-Man eating cat food problem. So I mean, really, he doesn't make a whole lot of money. How do you have an apartment in New York off of a couple of pictures a week? So sold to a guy who just constantly screams. I mean, it doesn't work out too great. He's got to be eating like, you know, tons of ramen, just tons of ramen. Spider-Man has radioactive salt per blood. All right. So he had 1 5/6 pounds. I hate you 2 pen. Kind of awkward because it's erasable ink and it's on a essentially dry erase paper. So it doesn't always flow nice. So this week, he had 3/4 pound less. So we need to figure out what that is. Well, that would be subtraction, right? We're just going to subtract a couple of fractions. So what we can do is, first of all, we got to get this guy to an improper fraction. So we take the 1, we're going to multiply it onto the 6, and then we're going to add it onto the 5. So we have 1 times 6 is 6, plus 5 is 11. So we have 11 out of 6. And we're subtracting that 3/4 from that. Okay. Well, now we got to get a common denominator. Anybody know the lowest common denominator between 6 and 4? Ah, you're going the other way around. That's actually going to be the greatest common factor, which we haven't done yet. So instead of the biggest number that goes into both of them, you want the smallest number that each of them goes into. 12. 12. You are correct, sir. Now, when we get to the greatest common factor, then hell yeah, absolutely. And usually I like to teach least common multiple and greatest common factor at the same time because I use the same method on both. And one of them you're working up to, and one of them you're just saying what they have in common. So this is the working up to. So the smallest number that both 6 and 4 go into is 12. So in order to get both of these to 12, we're going to multiply this guy by 2 over 2. And we're going to multiply this one by 3 over 3. And then each of these fractions multiplications, we're going to go straight across. So we get 2 times 11, 22 over 12 minus 3 times 3 is 9 over 12. So we get 22 minus 9. You just go straight across on top. 22 minus 9 is 13. And since this is a fraction, we still have the same denominator. Now, if somebody asks you how many pounds of something you ate, first of all, that's a weird question. And second of all, 13/12 is a weird answer. So we probably want that to be back in a mixed fraction. So what we're going to do is we're just going to say how many times does 12 go into 13? 1. And you'd have 1 left over, right? And that is how many pounds of cat food Spider-Man ate. Come on, Spider-Man, there's a Dollar Tree. I know it's $1.25 now, but that's still not much of it.
Is that cat food you found, or
Huh?
did you buy it?
Huh?
Did you find it or buy it?
I would assume bought, but you know what? It's more fun if we assume that he found a thing of cat food and decided to eat it. You know, 'cause that's just weirder, right? That's not okay. Like if you work at a hotel and you go into a room and there's a full pizza sitting in a box and you're like, I'm gonna eat that. You shouldn't do that. That's not healthy. I don't recommend eating things like that. Also, I worked at a hotel at one point. There's some weird stuff that happens. I don't know if I ranted about that yet, because I usually rant about everything, but we found a cheeseburger behind a painting on the wall one day. We don't know how long that cheeseburger was there. Nobody's really sure. It was from McDonald's, and once you get the moisture out of those things, they look the same forever. It'll kill you if you try to take a bite out of it, but it's going to look like it's fresh. Okay. The number 2, Aquaman is retired to a quaint attraction in SeaWorld. He is fed 4 2/5 buckets of fish each day. The sea otters are fed 1 2/3 times as much fish as Aquaman. How many buckets of fish are the sea otters fed each day compared to Aquaman? I wasn't bored that night when I wrote these. All right. So let's see. We got 4 2/5 buckets. And that's oh God, I find myself writing Aquaman buckets on my paper right now, and that's something I never thought I'd write. And then the sea otters, as opposed to your, standard household otters, are fed 1 2/3 times as much. I remember going to SeaWorld as a kid and not realizing that their entire lives were spent in those crappy little spots. Kind of messed up. Kind of messed up. Like when you're a kid and you catch a bug and you're like, I'm gonna put you in a jar and I'm gonna put a twig and a leaf in there to recreate what you're used to. I love that joke because it was by Mitch Hedberg, and he did exactly what I did as a kid. You know, it's like you don't know the difference between that and outside as long as there's a leaf. All right. So what operation are we doing between these two numbers? Anybody? Anybody? Bueller? Bueller? Okay, well, nice enough. We got the word times in there. You got the word times, chances are it's probably going to be multiplication. So we will take 4 2/5, and we're going to multiply it by 1 2/3. I have the temptation to show you how to do this without converting in a horrible application of the distributive property, but I'm not going to do that. It's an option, but I don't recommend it. That's the fun thing about math. There's always 100 different things you can do. The goal is to find the easy one. That's why you learn a bunch of stuff, because you don't want to do the hard way. All right, so same sort of situation. We're going to have to get an improper fraction multiplied by an improper fraction. So for the 4 2/5, we're going to take that 4, multiply it by the 5, so 20, and add the 2. So we'll have 22/5 multiplied by, we're going to get an improper fraction here. We have the 1. We're going to multiply that by the 3. So 1 times 3 is 3. Then we're going to add the 2 to it. So 3 plus 2 is 5. Oh, now here's something fun. Remember last time when we were canceling factors? I could multiply straight across. I was going to multiply straight across until I realized I ended up with a 5 up here and a 5 down here. At which point, why would I multiply across if I know that I'm just going to reduce by 5 later anyway? Well, let's do it now. 5's canceled to 1s. Now I have a 22 times a 1 on top and a 1 times 3 on bottom. We get 22/3. How many buckets do we need? 22/3. No, that's a terrible answer. So let's make it not sound stupid. So we see how many times 3 goes into 22. Well, 3 times 7 is 21, right? So we know that 7, that'll come in 7 times. And 21 out of 22 would leave us 1 left over. So we have 7 1/3. I have to say, we ended up with 7 students. So we did okay, but not that far. Not that far. The one thing I do like, I like writing the units. So it's buckets, buckets of fish. You know, Aquaman eats fish. I mean, I'll eat fish, but not out of buckets. I don't have many standards. I'll eat food from a gas station, but it won't be gas station sushi. You never trust gas station sushi. Gonna put that on my headstone when I die. People are gonna say, is that what did it? Is that what killed him? Just leave it up to them. Okay, Ben would rate his cranky level, his current level of cranky at about a 5. This is about 2/3 as cranky as usual. How cranky is as usual? How was I feeling when I wrote these problems? I know, about a year ago, actually, I've been copying this over for a while. Okay. So this one is a little bit trickier. And this will actually lead it into the stuff we'll do after proportions. So it'll lead into algebra, because I kind of threw that problem together and I said, okay, well, that's a good fraction problem. And then when I wrote it down the first time in the class, I was like, wait a minute, this doesn't work. And the reason it doesn't work for a standard fractional multiplying problem is because we're not looking for 2/3 of 5, right? I'm saying that 5 is basically the answer to 2/3 of something, right? So we kind of have to go the other way around. Now, before most of these math books get into algebra, they have such weird methods of explaining this stuff. And I hate them, and they're stupid, and you shouldn't learn them because you're going to learn a better way anyway. So we're going to skip that stupid idea because I decided it was going to happen. So the easy way to do this is with algebra. And if you've ever been terrified by algebra, don't be, because it is actually pretty easy. Case in point, we're going to look at this, and this exact sentence is going to translate to exactly what we want. So 5 is, okay, so if something is something else, then it's equal, right? So you see the word is, we got an equals. That's 2/3 of the usual. Well, what's the usual? I don't know. I don't have a freaking clue, right? So if you don't know something, then you're going to give it a kind of a fill-in spot, right? So that's going to be our x. We're going to say that the thing we don't know is x, kind of the standard, right? So if we're finding 2/3 of x, well, there's where our multiplication comes in, right? Now, you could write it as 2/3 times x, but when it comes to having variables, if you have a number out front of a variable, it's implied to be multiplication anyway. It's 2/3 times that thing. So we actually don't need to have a symbol between them. We can just say that 5 equals 2/3 x. 5 is 2/3 of something. What's the something? I don't know. That's why we got to get rid of the thing that's on the x. Because if we get rid of the thing on the x, then we'll have an x equals, and we'll be done, right? So how am I going to get rid of that? Well, it's a thing multiplied onto the x. So the general idea is that you're going to do the opposite operation. So if you have multiplication and you're trying to undo it, you're going to use division. Oh God, we're dividing by a fraction. Oh God, right? We don't like dividing by fractions, right? Dividing by fractions is annoying. So what did we do? Well, you leave the top thing alone and multiply the bottom flipped upside down. Now, is there going to be a difference because we don't have a fraction on top? This is just a number? No. What we're going to do, we're going to say it's 5 times, and then you flip this upside down. So we have 2/3 now, that becomes 3/2. And if you're thrown off and you don't know how to multiply a constant number, an integer, onto a fraction, you can always just put it over a 1. Now, if you can remember, that 5 is just going to multiply onto the top. Either way, doesn't matter. We end up with 5 over 1 times 3/2 is equal to, well, what's it equal to? We had 2/3 of x, and we divided off the 2/3, so what's left? 15/2. Well, I was going for x, but yeah, that's where we're going to end up. So yeah, we end up with 15 halves. We multiply across right there. Okay, not bad. If I say something's at 5 and that's 2/3 of the usual, and you say, okay, is the usual 15 halves? That's a weird answer, right? So again, we're going to clean this up. Now, at this point, since we're going to be going into decimals anyway, you could totally be lazy and throw that at a calculator. That's not a bad one right here. Otherwise, you could say, oh, 14, 2 goes into 14 7 times. It goes into 14 7 times, and you would have 1 left over. So I end up with 7.5. I don't know what my units are on this. 7.5 cranky. There we go. The usual's at a 7.5. If I hit 10, just gonna go to sleep. I don't care what my obligations are. Gonna curl into a ball. Cool. Do you have any questions on playing around with mixed fractions? Got nothing. Nobody's freaking out. Nobody sent me messages. We're gonna move on. Got a little bit more. Yeah, just 3 more problems of the review, and then we're gonna move on. Okay. So last time we went over unit rates as the last thing. Unit rate is comparing an amount of one thing to a single amount of another thing, like miles per hour, feet per second. I have no idea what else examples I can use. I don't care. Dollars per gallon for gas. That's technically a unit rate. So we're just gonna play around with unit rates. So on number 1, we have Laney bought a set of 20 markers for $6. What is the cost of 1 marker? Oh, you can't just open it in the store and try to buy one. You're gonna get kicked out. Be asked to leave the Walmart. I don't know what this is. I'm kind of freaked out now. All right. Yeah. That's my day. That's my day. Yeah. So we're looking for the unit cost per marker. So just look at how that is set up. If you have cost per marker, think of that as like the fraction you're going to make. That can lead you to thinking, okay, that's cost over markers, right? At which point, all we really need to do is put the cost over the amount of markers that it is. This one I'm totally going to do in decimals because we're talking dollar amounts at this point. Now 6 divided by 20, that's 3/10. Cool. 30 cents each, right? Cheap way of doing this, totally just reduce this in my head and then said, okay, 3/10, where is that in terms of decimals? Well, tenths is the first digit here, so that's where I'd put it. And if I'm calling it a dollar amount, we probably want to have that digit there too, right? It's cheap, but it works. I have totally done this on a test. Sometimes I mean, it's reduced all the way, but sometimes you don't even have to reduce things all the way. Sometimes you just got to reduce them just enough that it makes a little bit more sense. So 30 cents per marker. Let's do more. Okay. So if it took 7 hours to mow 4 lawns, then at that rate, how many lawns could be mowed in 35 hours? At what rate were the lawns being mowed? Okay. Now you could be really cheap about this. You could totally be really cheap about this because I accidentally set it up to the point where 7 goes into 35. So if you could see that and you think, okay, well, if I'm going for 5 times as much, then this is also going to be 5 times as much, which is literally the next header that I'm going to cover, which is proportions. It's a proportional relationship. There we go. That's why unit rates and proportions are usually taught in the same class, but I didn't have time. But let's play with that. Let's play with this for now. Let's just find the rate first, because we're going to need it anyway, right? We're going to say, okay, well, what rate is going to help us the most? Probably lawns per hour, right? I think lawns per hour. Would come in handy, because the tricky thing, and I've actually gotten mad at some math books for this, is that if I asked for a unit rate, I didn't really specify if I wanted lawns per hour or hours per lawn. Those are 2 completely reasonable things, right? Because you might want to know how long it takes you to do 1 lawn. You might want to know how many lawns you can pull off in 1 hour. Both of those rates are really useful depending on the circumstance. But which of these circumstances is going to benefit us the most right now? Well, we're looking for how many in 35 hours. So I bet if we found the lawns per hour, that would probably make more sense for us to find, because then we could just multiply it by 35, right? Okay. So if I'm doing lawns per hour, we're going to do it same way we did it up here. We consider that our fraction, right? Lawns per hour is going to be lawns over hours. I always like to set them up as a fraction before I do these. That way I don't like lose track. I have a really bad ADHD, so I try to find whatever way I can to just not lose myself here. Because, you know, sometimes you're just going to get lost. It happens. These things happen. Okay. So all we have to do, put our 4 lawns over 7 hours. You know, I bet you pull off 4/7 of a lawn in an hour. Because, I mean, that's a fraction that doesn't reduce, right? We've only been playing with fractions. This is actually going to work out to our benefit if I leave it as a fraction. I say that knowing I'm about to multiply this by 35. Because if that's our unit rate, 4/7 of a lawn per hour, then to figure out how many I do in 35 hours, I can just multiply, right? Because 4/7 lawns per hour multiplied by 35 hours. Think about the units being attached to those numbers. They're not just floating off in space, they're kind of there, right? That isn't just a 4, that's 4 lawns. This isn't just a 7, this is 7 hours. You know, those are specific things, and we are defining a relationship between them. So if I'm multiplying this by 35 hours, you kind of look at that as a fraction. And units actually cancel the same way. Because remember the previous problem where we were canceling the number on top and bottom? The units do the same thing. These hours are canceling these hours, and we end up with the unit lawns. That's actually incredibly useful, being able to do math with the units attached. That is literally the only skill I kept from engineering physics class. The rest of it gone. I don't remember a word of it. Somebody asked me a really basic physics question. I'm probably going to start drooling and freak out. So the units cancel. That is a wonderful hint towards your unit conversions to come in a few weeks or a month or however long it is now. I don't know. It's not really a long class. Okay. So now we can just look at the numbers. Well, the 7 and the 35 reduce, right? 7 goes into itself once. 7 goes into 35 5 times. So what do I have left? Well, in terms of units, we already talked about the hours canceling, so we know that what we have left is in lawns. Why would I ever care about this? Because if you have a bunch of stuff all thrown together in a row, sometimes you get jumbled, sometimes you put your fraction upside down, sometimes mistakes happen, and you end up with like foot hours, and you're like, that ain't right. All right, so on the bottom, we have 1 times 1. Okay, cool. Don't really have to worry about writing that, right? On top, we have 4 times 5, so we have 20 lawns. And as a short side thing for the proportion stuff, if you notice that we had hours and lawns like this. We ended up figuring out effectively a proportional relationship. This is the way you would set up this problem as a proportion. We'll be able to revisit that, no problem. But if you were to solve this, it would jump straight to 20. And in fact, if you're really cheap about it and you're like, oh, hey, this over here, that multiplies by 5. So this would also have to multiply by 5. So this would actually have to be 20. Good stuff. Oh my God, a tiny human. All right. Babies are like drunk people. Like exactly. They're not, you can't understand them. They can't stand up straight. They start falling over all the time and giggling constantly at things that probably aren't there. Probably. Huh? Thankfully, nobody has been dumb enough to procreate with me yet. Because my God, I'm sure that I would be better with kids if I had one. However, I did absolutely at one point Google whether or not it was considered child abuse to raise your children believing they were in the Matrix. I was just curious. It would be kind of child abuse because you are lying to them about the nature of the universe. Don't convince kids they're in the Matrix. Then you end up with like pretty much the thought of inception. Great movie. So this is the problem we didn't have time to do last time. Decided to slap it on here for review. We're reviewing the problem that we didn't do. It's fun that way. So this is a useful application of unit rates. So you'll run across this situation a few times in your life and you're going to be like, I don't really care. I'm just going to grab the one that costs this much. And that's how much thought you're going to put into it. But you can, in fact, figure out the best value of your purchases by doing this. And if you end up, say, in charge of logistics of buying buying, say the things at a business that you're going to be going through, like, you know, just your standard stuff, you might be able to save a ton of money by scaling this up by the thousands. So comes in handy. So each of these is a dollar amount for an amount of ounces that you're getting for a spice. Same spice, different values. So what I'm going to do, because we're obviously going to be looking for the best value, because, hey, we're going to be cheap here. I like being cheap. I'm also going to very slowly write these out, so I don't know how to drag that on. Maybe one of these days I'll actually write this stuff out in my notebook before it comes in. No, it's not gonna happen. Although I will say I totally planned the entire week in advance because this is slide number 7 of 48, and we're not going to get that far. Cool. So we got these different units here at different values. And we're going to figure out what's the best way to do it. And the best way, the units you'd probably be searching for would be cost per ounce, right? I'm just going to write it like that. $ per ounce. Good enough. Perfect. Absolutely. What's up?
Sorry.
It's okay. All right. So if we're doing it this way, we're going to use the 275 and divide it by the 22. We're going to figure out what that is. Hello, Mr. Calculator. Did you miss me? Yeah. Punch it into a calculator. You'll usually get something like that with too many decimals. I'm going to tell you right now, it's probably good to keep as many of those as we can, at least for the first couple. Because even though we're going to be rounding this to, you know, cents, well, some of them might be 12.5 cents, and some of them might be 12 1/3 cents or something like that. So we might actually be looking at, you know, tenths of a penny. It's a thing. It happens. All right, so the next one, same idea. We got 130 divided by 11. That's going to be a weird one. So my calculator gives me a nice long decimal. I'm just going to round it to the 3rd digit. So 0.118. So obviously this one already is a better purchase than that one, right? And we're gonna go down the line, doing this. That's 2, not a 3. That's a 2.
7.8 means almost 12 cents or
Almost 12
almost
cents,
12 cents, right?
almost 12 cents per ounce. This one is 12.5 cents per ounce.
Okay.
So we're looking at tenths of a penny. We're comparing tenths of a penny. But we're gonna do this exact operation for every one of these. So 293 divided by 30. Okay, so I get 0.097667. So if I round that to the third digit, that's going to go up. So I get 0.098. $198 divided by 19. You got 0.104. And then 225 divided by 25. You get 0.9. Or 0.09. Oops. I can read. Okay. So which of these is the best purchase? We're looking for the lowest amount. Which of these 5 has the lowest amount? Now, I did this intentionally because we don't have as many digits as the other ones, right? So if I end up with this situation, just think, well, is there anything there? No? What is nothing? 0. Now you can kind of compare a little better, right? So if I was just lining them up by those digits, 90 is lower than 98, right? So if 90 is lower than 98, then that is going to be the best one. So E would be our answer. It's the cheapest per ounce. Cool. Any questions? You happy to move on? And move this over. Shrink this down a little bit. This is gonna get shrunk down a little bit. See a notes being taken, and I don't wanna do that. I hated that when I was taking classes. Like, okay, you talked really fast, and then you're standing in front of the board while you're talking about it, and then you're erasing it all. And why am I here? You ever have those teachers? That sucks. That doesn't help anyone. Let's look at new stuff. We've got proportions. So proportion is simply 2 ratios that are equal to each other. So the comparison of the lengths of the shadow of a small object versus the shadow of a larger object would be proportional, right? Same sun's casting those shadows. So there we go. The angle is negligible at that point. Trust me, you don't want to play that game. So proportion can be used in many real-world situations, and a known value in a proportion can be solved for by using cross multiplication. For example, if a factory can manufacture 84 bicycles per day when it's at 70% capacity, then how many bicycles can be produced at 100% of capacity? So you would set it up as a proportion. So if you have like 84 bicycles to 70%, I would put the one over the other. I didn't really have a good way of writing this by typing into a slideshow. So it'll make more sense when I write it out, but I usually have my units top and bottom to kind of keep these proportions straight. Because keeping them straight is going to make sure that your answer is correct. So the fun thing is we're going to jump straight into examples. That's really, this is all the explanation we need, right? We can totally do this. I believe in us. You guys believe in yourselves? Yeah, me neither. I don't believe in me either. I don't. I've been told that confidence is a useful thing to have. I've been told this by many people that were completely aware that I had none. You know, it's real fun with anxiety. It's when you have a class and you have to, give the entire class your report, terrified to stand in front of everybody. Well, take the person that felt that way and put them in front of a math class for 2.5 hours. It's good stuff. It's good stuff. So we got some problems, right? So the number one, we have an 8-foot lamppost. Writing that down. And it's casting a shadow 12 feet long. A nearby building is casting a shadow 30 feet. What is the height of the building? I'm really big on just throwing problems together and never actually trying them out. This is one of the ones where I actually had to go and test it because I was like, I feel like whatever numbers I throw at this, I'm going to end up with like a 10-foot tall building and I'm going to screw it up and it's going to be dumb. So this one actually definitely works. I've totally done this before. Now, we have no idea what the height of the building is, right? No idea. Okay, if you don't know what it is, throw a variable at it. I don't care if you use X. I don't care if we use B for building. I don't care if you draw a small but delightfully shaded picture of an apple. I don't care. As long as it's something you don't know and you're going to solve for the thing you don't know, then you're good. So, as discussed, proportions are ratios that equal to each other, right? So, what's a ratio? It's a fraction, right? So we're going to have a fraction equal to another fraction. No problem, right? Cool. Now, when it comes to proportions, what I like to do, and I think it helps out a lot, is I like to put what it is I'm working with up here and down here. I like to write what it is I'm working with. So up here, we're going to say that these are, I don't know, these are our structures. And down here, we're going to have our shadows. That way we make sure if I have the structure to the shadow is equal to the structure to the shadow, then it's going to work out. Then it's a proportional relationship. So if I know I have an 8-foot lamppost that has a 12-foot shadow, then I can put the 8 up here and the 12 down here, right? Likewise, with the building, I have no idea how tall the building is, right? So that's just our variable right there. There's an X. We could use a Y. You can use pretty much whatever you want. and then its shadow is 30 feet. Now, I did say that these could be solved with cross multiplication. Now, there's a few tricks that you can use before we get that far. There's absolutely some tricks that you can use. So first of all, if either of these fractions can reduce, you can get away with that. You absolutely can get away with that. Why am I saying that? Because 8/12 reduces, right? 4 goes into both of those. 4 goes into here twice, and 4 goes into there 3 times. Because with proportions, we're talking about ratios that are equal to each other. And 8/12 would be the same as 2/3. Works out, they're equal for proportion. Now, when it comes to cross multiplication, this is how we're going to do it. And I'm going to explain why this makes sense, because a lot of times with math students, after talking about, multiplying fractions and proportions and stuff, the biggest mistakes I see people make are when to cross multiply. So I'm not just going to show you that we can cross multiply and how you cross multiply, but I'm going to show you why we can. So cross multiplication is effectively, it's a shortcut. Now, by doing this shortcut, what ends up happening is we end up multiplying kind of diagonally. So the 30 times the 2 will end up over here. Truth be told, it doesn't matter which side goes on which side. And then the 3 times the x is going to end up over here. So you literally cross across your proportion. You can only cross multiply when you have this proportional setup here. When you have a fraction equal to a fraction. That is the only time you can cross multiply. So let's solve it real quick, and then I'll show you what cross multiplication is a shortcut for. So to get the x alone, we're going to divide by 3 because the 3 is being multiplied onto the x to do the opposite operation. Opposite of multiplication, division. So we're going to divide by that 3. That'll cancel it out because 3 divided by 3 is what? 1. So it cancels out. Effectively, it turns into a 1. And we have 1x, which is just x. So whatever we're after is going to be on the other side. We have 60 divided by 3. That one's nice, goes in evenly. You end up with 20, right? Now, this was a word problem, so you always want to give your units. So the building was 20 feet tall. Yeah. So I said I'm going to show you why cross multiplication makes sense. So let's do it. Now there's 2 other methods I could have used. Both are perfectly reasonable, but either way, the idea would be to reduce a fraction. Let's say that I was mostly concerned with getting rid of my fractions, right? Because you guys, I know we just did a ton of fractions, but you probably hate them. You're probably going to hate them for a while until you do 1,000 of them in a row, and then you're like, okay, they're not too bad. But let's say you wanted to avoid fractions, because sometimes that comes in really handy. One method of avoiding fractions is by canceling all of the fractions out. So what you would do, and you can only do this when it's an equation, because what you do to one side, you have to do to the other. What you would do is you would look for the common denominator across all of your fractions. Well, 3 goes into 30, so that's great, right? So what you would end up doing is you would end up multiplying both sides by the common denominator. What happens over here? We got 30x divided by 30, that just cancels, right? What happens over here? Well, the 3 would go into that 30 10 times. What's 10 times 2? 20. Okay, well, there's another way to do it. End up with the same answer. Okay. Now, another thing you'll see, another way of getting rid of the fractions, let's say I didn't even worry about the common denominator. Let's say I wanted to multiply through by everything. Let's say that I didn't have nice little fractions or a good common denominator. Let's say I didn't have a good common denominator. Let's say that I decided to take the 3 and the 30 separately. If I was gonna cancel everything out, I would have to multiply the 3 and the 30 onto both sides. Because what you do to one side, you have to do to the other. Now I've effectively multiplied both sides by 90. But what ends up happening? What was already on that side gets canceled out, and you're left with the other factor. Well, where did that factor come from? Well, that came from over here. Okay, well, what did we multiply by over here? This 30? Okay, where'd that come from? That came from down here. So what ended up happening is this ended up crossing and multiplying over here, and this ended up crossing and multiplying over here. Now, if you don't worry about common denominators, this works every single time. And because that works every single time, honestly, this just kind of looks like it sucks to write, right? We don't want to write that, that's messy. So we developed a shortcut. If we can see that this number is going to multiply up here, and this number is going to multiply up here, just draw an X between and multiply it that way. And as long as you do it that way, then it works out real quick. Quick, it's easy, and cross multiplication is a shortcut, and I hate that it's never taught to be a shortcut. They teach it like it's its own thing. Really not, it's a shortcut. But I will see sometimes people multiplying two fractions together, and then they cross multiply them somehow, and I'm like, wait a minute, what you do, don't do that. That is the most common mistake I see, because it's never explained well enough when and why you cross multiply. And now you have had that. It is now on your belt. You will forget it in about 20 minutes. That's how it works. Any questions? Cool, I also don't have a question for myself. Let's do another. Number 2, Theo wants to use a cookie recipe that makes 36 cookies, but he wants to reduce the number of cookies to 24. I'm going to write out 36 cookies, and I'm putting kind of a little arrow to 24. That's kind of just good shorthand for myself. If the recipe specifies using 2 cups of sugar, how much sugar should you use? Okay. We're not gonna concern ourselves with doing this a hard way. We're not going to concern ourselves with the long way of doing these things because we know how to cross multiply. We know the shortcuts. So again, we're doing a proportion. Proportion is a fraction equal to a fraction. I like to have certain types of units up top, certain types of units on the bottom. So I'm going to go ahead and put cookies on top and cups on the bottom. You might ask, Ben, does it matter if I put cups on top and cookies on bottom? Not in the slightest. If you flip both fractions upside down, they're still in a proportional relationship in the exact same way with the exact same unknown, and it works out the same every time. Does not matter. So I could have flipped those, wouldn't have mattered. Okay, so my first one, we know that over here, we're going to probably put our 36 cookies, right? And the recipe that has 36 cookies has 2 cups of sugar. But then over here, we're going to go down to 24. And we don't know how many cups of sugar. Well, if you don't know, you can use whatever variable you want. I'm not going to stick with X because I've noticed that students who do nothing but problems with the X get really, really concerned when they're suddenly thrown into something with a different letter. And there is literally no difference to the method. I don't care what letter that is, you're good. So again, we have this nice little setup. We can cross multiply, right? Multiply that way, multiply that way. Now you could see that this would reduce. Now I'm not going to reduce that for now. I'm going to show you what happens if I don't. And the main reason I'm not going to reduce that is because this would turn into a 1 and that would kind of undo the need for cross multiplication and it just end up kind of weird. It'd still work out, but I just don't want to deal with that. So we multiply the C by the 36. We end up with 36C. And we multiply the 2 by the 24. So we end up with 48. And then we can divide both sides by the 36 because we have 36C. We're trying to get the C alone. So we need to cancel out that 36 by dividing it. And we end up with, well, I'm just going to rewrite it here, but we end up with 48 over 36, right? And we can very clearly tell that's going to reduce, right? Now, does anyone know the largest number that fits into both of these? I'm not going to just expect everybody to know that for the record. Anybody have a clue? Huh?
18.
18? No, not quite. Not quite. 18 doesn't go into 48. Not even, I should say. We're actually going to go with 12. Yeah, 12 goes into 48 4 times, and 12 goes into 36 3 times. We get 4/3. That seems nice. 4/3 of a cup. Do I want to convert this to a mixed fraction? Not really, but I'm gonna. Because 4/3 doesn't always work out. You might say, okay, 3 goes into 4 once, and you'd have 1 left over. So you'd have 1 1/3 cups. Because chances are your measuring cup isn't going to give you 4/3. It might. I don't know. Depends on the measuring cup. Now, one thing I was going to show you, I ended up reducing further, so it didn't go quite to plan. But one thing I was going to show you is, notice these guys would have reduced right here. If those had reduced, both of these numbers would have been half as big. Because the 2 would have actually canceled out before we got to them. So if you run into this, what ends up happening is if you don't cancel early, you end up canceling late anyway. Does it matter when you do it? No, but you might end up with bigger numbers than you had to. Another thing I would want to say is that I don't often like the way that teachers will teach you how to reduce. I don't like the way that teachers like to teach reduction, because it took everybody, we're all staring at this, like, what's the biggest number that goes into both? I don't know off the top of my head all the time. And sometimes when you're dealing with, high up there algebra and stuff, it is not uncommon for me to end up with like 6-digit numbers over 5-digit numbers when I'm playing around with higher level math. And I'm sure as heck not going to be able to tell you what the biggest thing that goes into those pulls off. So what I like to do is I like to say, okay, what's the simplest thing I could see goes into both of these? 2, right? They're both even. Cool. Chop them both in half. That's perfectly safe. You can do that. If you look at that and say, oh, well, they're still both even. Cool. Chop them both in half. End up with 12 ninths. Hey, 12 ninths. You can see a 3 goes into both of them. You end up with this. So what is 2 times 2 times 3? Because we reduced by 2, we reduced by 2, and then we could see another 3 happening. 2 times 2 is 4, times 3 is 12. So you end up reducing by 12 anyway, if you do it that way. And if you do it that way, you might not be sitting here all day trying to go right from here to here, because you can absolutely go incrementally down. They don't like to teach it that way because you're not magically done in 1 step or 2 steps. But I think it's easier to be able to see things that way. Because I'm not going to magically be able to tell you what goes into giant numbers. Yeah, like if I punch something horrible into my calculator, how did that reduce to that? I don't know. I have no idea. But I'm absolutely not going to sit there all day and try to test every number to get it in 1 step. I would 100% just start throwing the tiniest numbers I can at it. Apparently those numbers that I pulled out at random reduced by 29. I wouldn't have gotten that. Is that a prime number? Does that just completely undo everything I just talked about? Yeah, let's not talk about that. All right, you don't want to do that. You get to that point in math, you just throw it as you circle it as a giant horrible fraction, or you make a decimal and you call it a day. Oh, what am I doing? This was number 2. So we're doing number 3 now. It looks like a 3. You've all done that. Everybody's done that. I did that like 40 times today because today's the 30th and I kept starting to write the 29th. Okay, so in order to determine her pulse rate, June's nurse counted 18 beats in her pulse in 15 seconds. You could probably already tell where this is going to go. At this rate, how many beats would she have per minute? And to be fair, this isn't the nicest problem to do as a proportion, because there's an easier way to do this problem. We all know the easier way to do this problem is multiply by 4, right? Because there's 15 seconds goes into a minute 4 times. So whatever is going to be here is going to be 4 times that. But if we didn't know that, and we just knew that this was some thing, this is some amount of beats. That's something. Okay, well, we cross multiply again, right? Same as any other proportion. You multiply this over there, you multiply this over there. Now, I don't really like these numbers to multiply, right? So I can see that the left side is going to reduce a little bit. I'm going to do that first, because I can see 3 goes into here and 3 goes into here. So 3 goes into 18 6 times, 3 goes into 15 5 times. One random letter you might end up avoiding in the future is the letter B in algebra, because sometimes my B's look like 6s and my 6s look like B's. Well, this is nicer to cross multiply, right? I like this one better. So we're going to multiply 6 times 60, so we have 360. Why did I start writing that as a fraction? It's not a fraction. And then 5 times B is 5B. And then you can divide both sides by 5 to get B element. Go over to Mr. Calculator, it's probably 72. It was 70. Does anyone want to know how I did that in my head? Does anyone care? It's really cheap. Going to do 360 divided by 5. I can't do that in my head. You know what I can do in my head? If I multiplied this by 2 over 2, that would be 720 over 10. Can I do that in my head? Yes. All I had to do to be able to do this in my head was to be able to tell that 36 times 2 was 70. You need to know this now. Might it come in handy? I don't know, if you do a ton of math in the future. I try to work on my mental math as much as I can, because honestly, I don't care if I have a degree in this. I am so bad at mental math. I have seen people, I've actually tutored people who could dance circles around me in mental math, but they just didn't know algebra. But they would be able to multiply 4 digits times 4 digits in their head. And I'm like, how did you just do that? I can't do that. All right, how do we feel about proportions? We feeling good? You happy with them? The main reason I'm asking the question is because I don't know if I want to do all of these. I don't know if you guys want to do all of these. Let's do number 5. I feel like that's one that would actually, be something you might do in the future. So number 5, we have Mal's total bill at a restaurant is $34.75. He wants to leave a 20% tip. How much is the tip? These are actually really easy to do in proportions. Because all you really have to ask yourself is, well, if you're trying to figure out 20%, what's 100%? The original amount, right? So if I say that this is 100%, and we're looking for the dollar amount for the 20%, well, there's our proportion right there. We can look for dollar amounts over percentages and set it up that way. So we have 34.75 is 100%. And then we don't know what the 20% is, but we know the 20 is down there, right? Because it's our percentage. And I don't have a clue what's up here. That's what we're trying to figure out. So all we got to do is cross multiply. Embrace the calculator, end up with 100x is equal to 3475 times 20. Well, it moves over one digit and it doubles, and I don't know what that is off the top of my head, and I don't care. And neither do you, because once we do this, we're not going to do it again. 3475 times 20. Oh, that goes in evenly. We end up with 695 even. Well, that's cool, because when I divide both sides by 100, the nice thing about dividing something by 100 is all I really got to do is put a decimal in there and call it good. If you're dividing by 100, you're dividing by 10 and dividing by 10. It's over twice. So 20% of this bill would be 695. And then if you needed to know your total, you could just add the two together. You're good. But it works. Are we feeling okay to move on? Feeling okay? Feeling okay. Let me get your guys' opinion on something before I move on. In previous classes, I usually let people out for a break in the middle of it. It's a nice idea, but usually when people come back, well, some of them don't. And other times, that's your brain, that little taste of freedom kind of turns your brain off. That happens. So my question to you guys is, keeping that in mind, knowing that you do in fact kind of want to know this stuff, if I give you guys like a 10-minute break in the middle of classes, is it going to work for you, or is it going to not work for you? How are we feeling?
Sure, yeah. I gotta use the restroom anyways, instead of holding it.
Dude, why? This is a college class. Just walk out the door. Do not.
I didn't want to miss a thing, that's the point.
Oh,
If I can hold it, I'll hold it.
yeah, you know what's really bad is sometimes when I'm working at the plasma donation center, some people decide that they're going to try to hold it. You know what? You're sitting there for like 45 minutes. The room's kind of chilly. And you're literally just sitting there on a bed like this. If you're trying to hold it, it's not going to work out great. So yeah, I like it. What's my shortcut for a new slide? Control M, click to add title. Break until say 7:32. Why not? PM. Pacific Standard Time. If anybody has any questions, I'll be here. But you won't. You don't want to deal with it. I'm going to take this beautiful time to sit down. Weird if I pulled up my terrible teacher. They should have just canceled the class and go to sleep.
7 hours in the last 3 days.
I physically can't do that anymore. I used to do that a lot. Physically, like, you know,
I'm used to it.
I used to be. I used to tutor for 19.5 hours per week on top of a full-time job. Can't do that anymore. Eventually, I just slowed down. Very tired.
Me too.
Oh yeah, you win that contest.
Sergeant, right?
I had to be at work by 8 a.m. Bike there. I live down the road here. I work past Target. So I had to get up very early. Start biking. After I got out of work. I went to work. Games. Another 6 miles. Home. Ate something really fast. Here.
Yeah, we saw you when I was driving up. I saw you.
You guys see me all over town. Only biked 14 miles today. Off of an 8-hour shift. Where I got signed off on plasma processing and observed by a training coordinator. We had 2 tests. And I went back to the lab and nobody was there. All these bottles of plasma off to the side, and I'll have to be in the freezer like 30 minutes after. Already been sitting there for over 10 minutes. Apparently now process a bottle of plasma.
¿Cuántos haría al 100%? La empresa que me piden, aquí le ponen 45 por dividido en 70. Tiene sentido porque si al 70% lo puede poner 21%. Ella quiere saber cuántos puede poner la cabeza. O le vamos a poner cuántos minutos para el how many minutes you will take to have, whether it's a big or simple. I think that's what it's saying. You're going to have to do that. You're going to have to do things like that. Pero ¿cuál va a tener?
All right, who's ready for algebra? You guys excited? This is easy. We're doing easy algebra. It'll be fine. Not planning on hard algebra for a while. I just want to be able to use algebra problems. math books would normally have really obscure ways of talking around things being algebra problems. Like the problem I did earlier. It's easier just to throw an X in there. It's all good. So, linear equations. I'm being a little bold by throwing this kind of earlier on into the class before some of the other subjects, but I think it'll work out just fine. So linear equations are equations with just a plain old variable like x. Rather than something more complicated by x squared or x over y or square roots or other more complicated stuff, they're just things that represent lines. So linear equations, I actually hate calling things with one variable a line because it's kind of a dot. But when they have two variables, that's when they go up to having essentially representing a y and an x. They represent a line that way because for every x, there's a y. But for now, we're only really going to be playing around with the ones that have one variable. Case in point, literally all the problems we've played around with today kind of fall under this example. They're all linear equations to this definition. So we've been doing them all day. Don't stress. So the main thing I see as a problem when it comes to learning algebra is that a lot of people are like, you know, you'll have a problem where you have to find out what to add to 3 in order to get to 5. And everybody can kind of do that in their head, right? You would say, okay, well, you count up and say, okay, 2 more, right? And they're like, why do we need to use this? Because it gets harder. Because it gets harder. So you want some direct ways of doing these things that scale up. If I have a nice way of doing this problem that's really, really basic here. Welcome to the party. If I have a nice way of doing this problem, even though it's an easy problem, that method will work for anything like that. You know, if I had to figure out what to add to 572 to give me 3,437 or something like that, it would be the exact same method as this. So you would look at this and say, okay, the thing I don't know is my unknown. It's my x, just like we were doing on the last several problems. And we just set it up. If we need to know what to add to 3 to get to 5, we can write it as x plus 3 is 5. Something plus 3 is 5. There we go. So you just kind of replace the word something with a variable. Totally didn't expect to do all the examples that I did earlier with a bunch of algebra, and then this slide is kind of like, oh yeah, let's do this. Cool, we've been doing that already. So in order to solve linear equations, you basically just have to undo whatever is happening to the variable. So if I have x plus 3 is 5, we have to get the x alone. So you do whatever you got to do to get rid of whatever's attached to the variable. In this case, we have a plus 3 on it, right? Well, how would you undo plus 3? Take it away. You would subtract 3 from both sides. You get a nice little algebraic way of doing this problem, right? That's algebra. And in its base form, that's all of algebra right there. Pretty much the concept. So solving any linear equation works about the same way. How do you undo multiplication? Well, we just did that a bunch of times. You do it with division. How do you undo division? Use multiplication. How do you undo subtraction? You use addition. So you're just kind of going the other way on things, and you're canceling stuff out. So if I looked at this problem, I have x divided by 4 is 3. Okay, well, how do I undo division? Multiplication. So you multiply both sides of that thing by 4. So you're just trying to get the exelum, or whatever your variable is, the y, the z, the I don't care, a small picture of a grapefruit, whatever your variable is. Just to demonstrate that concept, at one point, I absolutely used the entire word monkey in capitals as a variable, just despite a student who didn't think I'd do it. It was a lot harder of a problem, and I got really tired of writing the word monkey, but it worked. So we are now at the what you do to one side, you have to do to the other stage of algebra. So the best way to think about that is think of the equal sign that as being like a balance. Both sides are equal, they're both balanced. So if I double one side and I don't double the other side, you just offset the scale, right? Balance is off, everything blows up. Up is down, black is white, cats and dogs love each other, the whole 9 yards. So you just if you kind of think of the symbol as like a physical balance, that keeps you from making a lot of mistakes that way. Kind of a weird way to look at it, but it's helped me over time, so. Don't be part of the problem, be the entire problem. How I like to live my life. Let's do a bunch of random problems. For the record, that is a screen capture of Star Trek: The Next Generation. Because I am a frickin' nerd. No apologies for being a nerd. Who else do you want to teach you math? Do you want somebody who does gym that's teaching you math? No. You want a nerd teaching you math. I'm gonna write these all out real quick because honestly, these are gonna be quick. These are all very simple problems that we can get in one step. Now you'll notice on number 4 and number 5, I wrote those kind of oddly. And the main reason I did that is because really, there's not a nice way of typing fractions into Google Slides. So what I have in parentheses, I have parentheses 2x/5. That's meaning that the 2x is over the 5. And on the next one, I have a 1/5 in parentheses and y. That means there is a fractional 1/5 outside of a y. You'll see that in a second. Look at how much room I gave me. These are going to go quick. It's not going to be bad. Well, can't really hear me. Can anyone else online hear me? I want to know. You guys hear me? You just rolling with it? Throw stuff in
Yes.
the chat. You hear me?
Yes,
Cool. I also hear me. It actually might be your PC. Try hitting your computer with a hammer. See, you heard that. Yeah. Yeah. I'm cheap. Hit it with a hammer. It's great. It works great. Don't whack the PC with a hammer. Like when my computer was making horrible noises. The fan was making weird noise, and I just kept whacking that fan. I'm like, this is breaking it. I know it's breaking the fan. I don't care. It's annoying. I've had to replace that exact fan 3 times on my computer. Am I going to get a better fan? No, I'm just going to keep using the cheap ones and getting angry. I'm an adult. Okay, so I did send you an email a little while ago. If you still can't hear me, I can't really fix that, but I can upload this class to YouTube. if you would like. The only reason I haven't been doing that this class is because I spent a really long time doing that with the last several classes. And sometimes some of those videos get one view. That's it's really annoying to upload 2.5 hours of math every couple of days. And then nobody looks at it. You do need better speakers or a headphone, set of headphones. Because I am a sucker for headphones. Ever need headphone recommendations? I am your guy. Realistically, any level of technology, I am your guy. I am a nerd again. Okay, so let's do math. Are we excited about math? Are we happy? Look at all our problems. Are we happy to do these problems? Oh, you're definitely not happy to do these problems, but I bet you're going to be able to do them. I believe in you. You got this. I mean, you're going to be lost. No, you're not going to be more lost. It's just hard to get back into math. You haven't done math in years.
7 years.
Yeah.
8 years.
It's not like riding a bike. And by the way, I totally didn't ride a bike for many years. And people say, oh, it's like riding a bike. You never forget. I forgot.
I never learned.
I grew up in Stockton, California, but so the way I learned how to ride a bike was stealing someone's bike. And then I hit a tree because I didn't know how to stop the bike.
That way.
Yeah, I'm glad I moved. That's a bad place. If you're ever driving through California and you find yourself in Stockton, first of all, lock your doors, and second of all, your car doors are not thick enough. People like to shoot people. It is frequently on lists of the most dangerous towns in America. Good old home. Anyway, like I said, that sucks. Oh yeah, I'm doing math. I'm bad at this. All right, cool. So we have 2 plus x equals 6. We gotta get the x alone. What's in our way? The 2, right? So we want to get rid of the 2. The what?
2x equals 6? No.
2 plus x equals 6. Yes.
What the x means, what
It's some number that we don't know.
the value of the x.
That's our goal.
Oh, I see, okay.
Yeah, so all of these x, even though these all have an x on them, each problem has a different x. The x is just a stand-in for, I don't know. So it's 2 plus, I don't know, equals 6. So what's the, I don't know? Well, we got to figure that out, right? So the idea is that if you get down to the point where x equals, well, then you know, right? So the whole goal is to, again, I hate how a lot of these things are taught. The whole goal is to get this thing alone. So what I usually say is kind of just start chipping away at it. Now, like nice enough, I set these problems up to be 1-step examples. I'm going to have 2-step examples after this. Don't worry, they all get harder. This gets much, much harder. It's going to be fun. But all of these can be solved in 1 step because right now what's happening to the x? Well, it has 2 being added to it, right? We have x plus 2. We have 2 plus x, but it's still the same as x plus 2. Same thing. So how do I get rid of the 2? Well, right now this is a positive 2. If you want to cancel it out, you do the opposite operation. So right now this 2 is being added. So what we're going to do is we're going to subtract. So we subtract the 2 because, hey, what's 2 minus 2? Not there. That's what we want. We want this x to be alone. So once I cancel these guys out, all I have left over here is x. On the right, well, we have to actually subtract the 2 from the other side. What we do to one side, we have to do to the other. So we have 6 minus 2, we get a 4. And that would make sense to be our thing, right? Because we didn't know what it was before. 2 plus, I don't know, equals 6. Well, wouldn't it make sense if that was a 4? Yes. And that's one way you can go back and make sure that you're right, is you can check your answers. Normally at this level, you don't really need it, but that is always something you can do. You can go back and plug in what you got as your answer to your original problem and make sure that both sides are the same. So you get 2 + 4 = 6. So 2 + 4 is 6. So it's the same on both sides. So you're peachy. We're happy. Everybody's happy. I am really thirsty. My gallbladder hurts. That's not a good thing to hurt. At least it's not stabbing right now. But I've been ignoring going to the doctor and getting an ultrasound. I know it's gonna have to be cut out of me.
Why not do it in the easy way instead of like that?
Well, you would look at this and you would say, okay, 2 + what = 6, and you would do that in your head, right?
That was what I was thinking before the beginning. The way you go over the side,
Well, the steps.
huh? Why don't you go over the steps instead of doing the easy one?
Would you be able to do this in your head?
No, that's too many numbers.
There we go. Because this exact concept would solve this problem. Because in order to solve this, well, how did we solve this? Well, we had something added to X and we just subtracted it off, right? Okay, cool. Well, how would I solve for X? We have something added to X. So you would subtract it off. So the entire concept here is not that, yeah, there's an easier way to do it. The problems like this can be done in your head, but higher applications of this method, that's what you're after. If you could get it down here, you can get it down here. You end up with some giant, horrible, since I'm writing this down and people might end up with it in their notes, I'm actually going to go ahead and get an answer. In that case, it's -5405. I couldn't do that in my head. You couldn't do that in your head, but it's an example of something you could do just by getting down this method. Same sort of thing we have on number 2, we have 2x = 30. Yeah, that's something we could pull off in our heads, but if we get the concept down, we can do significantly harder problems. So for number 2, we have 2 being multiplied onto the x, right? If we have 2 multiplied onto the x, in order to undo that, you do the other operation. The opposite operation to multiplication would be division, right? So if I have 2 multiplied onto x, and I wanted to get that x alone, I would have to divide both sides by 2. So 2 divided by 2 cancels out, we just have x. And 30 divided by 2 is 15, right? I'm gonna box my answers because this is kind of getting, I totally shouldn't have written these this close, but you know, sometimes you live and learn. And sometimes you don't live and learn, because I've taught this class multiple times and I still do it. Sometimes you're just dumb, stuck in your ways. That's what applies to most of my life. All right, so number 3, we have x divided by 6 is equal to 4. Okay, x divided by 6 is equal to 4. Well, it's being divided, right? We want the x alone. So what would cancel out division? Multiplication, right? So you do the opposite thing to it. You would multiply that 6 onto both sides. That would cancel the 6 on the left and give us the x alone. And on the right, we have 4 times 6, which is 24. And yes, you could say what divided by 6 is 4, and you would get to the answer. But harder applications of this, 50-50 on whether or not you can pull it off. Something like this is weird. I don't want to do that. That didn't even add in multiplication or division. By the way, after I do decimals and percentages, I am going to torture you guys with algebra problems. I just want to give you a heads up. They're going to be ugly. You are not going to have anything that ugly on the GED or the high set or whatever you take. Algebra is definitely going to be ugly.
Yeah.
Oh yeah. Oh yeah.
This one too?
So this is like the building blocks of everything that is to come. So this is going to be built on top of many, many times. Now, am I going to build on top of it right away? Not so much. But we will be using linear equations later in the class to start doing graphing. There's some interesting applications with inequalities where we start getting ranges of numbers in terms of having a line separating things out. That's kind of funky. That's another thing I hate how it's taught, because honestly, there's so many easier ways to teach this stuff that drives me freaking nuts. At some point, I'm just going to take all my slideshows, format them into a book, and then just put it on the internet and give it away for free. Okay. Number 4. The next two, I decided I wanted to make it a little bit harder, because of course. So there's a couple of ways to look at number 4. Number 4, you can look at and say, all right, well, that's a 2x being divided by 5, and it's equal to 8. Now, you remember earlier in the class when we were playing with fractions, and I kind of showed this concept off where it didn't really matter where the the negative was. Well, that same sort of thing kind of happens with the x, not exactly, but it kind of happens with the x because you can look at this as 2x over 5, or you could look at it as 2/5 x. Anything hanging out on top can come out front. Kind of funky. Gonna zoom. We're zooming. Now this is probably really big. I don't really know. I hate that there's a TV. I hate that I don't have a projector again. Ooh, technology, cool. Have a smaller screen. If I had a projector, it'd be going from that side to that side. That's a heck of a lot bigger than the TV. But this room would be cool for movies. Maybe I'll figure out when the room is vacant and just decide to use it. You can totally do that, by the way. I have seen study groups just take over classrooms here. It's bad. Just pick an empty room, be like, yeah, nobody's in here. Let's go in here. And just use the room. Cool. So the reason that I want to be able to stress that these are equal is because you can actually cancel it out that way. So if you think of this as kind of a fraction happening to the x, well, how would we get rid of a fraction? If we thought of it as a fraction being multiplied onto the x, well, then we'd have to divide, right? Because multiplications happen. Well, I don't want to divide by fractions, and neither do you, right? We want to avoid dividing by fractions all we can. So what did we do before when we divided a fraction by a fraction? We flipped and multiplied, right? That's actually what we're going to do. We're going to multiply both sides of this guy by what's called the reciprocal of that fraction. So you just take that fraction, you just flip it upside down and multiply. Because, hey, When it comes to with the canceling, like before, now we got 5s cancel and 2s cancel and whole thing canceled, right? What do we have left? X. Now over here, you could do it a couple of steps if you want to. But what I'm going to do, I'm going to put that A over 1. I'm going to put 2 and say this 2 cancels with that 8 down to a 4. Wow, that is the worst canceling I think I've ever done. It just kind of went with the slant on the 8. Now I got like a fan happening here. I don't know what I just did. This is math art. All right. So you multiply straight across, we end up with 4 times 5, which is 20. So 2/5 of something is 8. I would not have been able to do that in my head. We end up with 20. Now, if you didn't cancel like this, you would have just multiplied straight across. You would have ended up with 40 over 2, and you just would have had another step where you chop that in half. So if you do it that way, that's fine. If you do it this way, that's fine. Do it however.
How can, in the representation, how can you obtain the number 4? Because I was confused and thinking it is.
This guy? Okay. Fun lessons, fun lessons. Okay. So effectively, I want to use 8 over 1 and 5 halves again. But I will. Okay, so essentially what's going to happen when you multiply 2 fractions together is you multiply straight across, right? We end up with 8 times 5 on top, and we end up with 1 times 2 on the bottom, right? Well, what ends up happening is, well, we would end up with a 40 on top and a 2 on the bottom. Those would reduce, right? By 2. Well, what happens is because we're multiplying these 2 guys together, we kind of just get the combination of those factors on top and bottom. And if you have something that will reduce in a fraction, you can reduce it, right? Well, since we know that these are going to be the factors on top and the factors on the bottom of one fraction, whenever you're multiplying fractions like this, you can kind of take a shortcut and say, I know that these are going to end up being, this is going to end up on top of this one. So we can reduce it now rather than later. 2 goes into itself once, 2 goes into 8 4 times, and that's where the 4 comes from. Make sense? Ish? Okay.
No, yeah.
Okay, I'll take it. And I totally didn't know that that went off the screen. No idea. God, I'm bad at this. All right. How we feeling so far? We terrified? We happy? 30 minutes left. There's 30 minutes left. You're watching that clock, huh? Okay, it's 29 minutes. I'm watching it harder. You know, if I get to the point where I can round up, I actually might. It's all about good stopping point. And we don't have a good stopping point yet. Hey, look, we have a number 5. Don't forget about that. He's still here. He wants to be our friend. Oh. We are happy. All right. Okay. Cool. So, number 5, we have 1/5 y is equal to 6/35. How do we feel about this one? Do we feel that this is as hard as the last one, harder than the last one? Just as hard, easier? What do we got? How are we feeling? Not good with reading the room. I don't know how to read people. I'm good with math, I'm good with technology, I'm not good with people. I don't know why I'm teaching. I have no faith in me, and neither should you.
I have one thing to do with the user.
Sounds awesome.
Okay.
Have a magical evening. Nobody wants to talk. I don't like. I don't want to talk to you. Am I dissociating while I'm teaching class? Sure am. All right, so. Right now, we got 1/5 times y. Same sort of thing happened up here. We had a fraction on a variable. We decided, hey, we were going to, instead of dividing off a fraction, we were going to multiply by the reciprocal. Reciprocal. I think that's how you spell it. I don't know. I don't teach English. English is a god-awful language, by the way. It's terrible. Like I know this, I know I ramble a lot, but it's like the actor Sean Bean. Sean Bean, E-A-N, E-A-N. Why are those pronounced differently? It should be Sean Bean. Or Sean Bond? Sean Bond? Yeah, English is terrible. I just want to know if anybody's going to end up with the name Sean Bean in their notes. So we're doing math. We have 1/5 of y is equal to 6/35. Now, yes, I could very well multiply both sides. You're just shy. Me too. I'm teaching. You don't know how terrified I was when I started teaching this class. I think I was on a anti-anxiety med called hydroxyzine in the same class as Benadryl. You take a Benadryl to fall asleep. You ever do that? You ever take 3 and decide you're going to teach a class? But I did it because I was not falling asleep because I was freaking out. I really don't want to be there. Very tired. This is where we're going to end with this problem. Are we okay with that? Is anybody not okay with that? If even one person's not okay with that, I will stay for another 25 minutes and do math. No? Okay. Cool. You know what we're going to do on both sides? We're just going to multiply by 5. Because I have 1/5 of what? I don't have to multiply by a complicated fraction. I don't have to. I can just multiply both sides by 5. Look at that. Isn't that beautiful? Because what happens? The 5's cancel. Okay. Now, 6 out of 35 times 5. We can either multiply across or reduce. You want to reduce? I like reducing. We're going to reduce. Because remember, you can look at this as 5/1 and see it as 2 fractions multiplied. So you can reduce this. So the 5 goes into itself once. The 5 goes into 35 7 times. So, well, that's great because this fraction ends up just being multiplied onto a 1, right? I love that. That's great. So I end up with 6 times 1 over 7 times 1. I end up with 6 over 7. It's beautiful, right? Beautiful. I apologize if I end up shortening other classes in the near future because they have me going in at 5:30 every day next week. I don't want to. So I might just find a way to teach you more math in a shorter amount of time. Okay, I can pull that off. All right.
If you
so
want
I'm
a
gonna
copy, I
call
can
it
send
good.
it to you. I recorded that. I needed
What you record? What?
that whole lesson, those 4 lessons you just did.
Okay, all right. So I used to record all my lessons and put them on YouTube. If you guys think you would use it every once in a while, you don't have to do it religiously. I don't have to like stare at the view count, but if you think it would be a good resource for you to have, would you like me to upload these lessons to YouTube? I am willing. And I do in fact have recordings of the last couple of classes.
Well, the point is, if there's only one view,
Yeah.
is it worth it for you? I would love to, I would love to.
If it's helping one student, then yes, I'm okay with it. If literally one person clicks on one of the videos once in a while, I am willing. So we think we like that idea? Okay. I got something to do in the next couple of days because today's my Friday. So, all right. So by the next class, might take me a couple of days, but by the next class, I will upload all the recordings to YouTube. I will put them into an email, and honestly, I'm probably just gonna hit reply on my email I sent out before. Lazy. No, I got news too. I'm gonna send out a new one. Gonna send out a new one. It's gonna have all the links you need. You can save one email. That way, if you're home and you gotta do Zoom, you could do Zoom. I don't care. We're gonna make it work. We're gonna make it easy on everybody. This recording is going to end up on the YouTube. And then when you're on there, you're gonna be like, oh God, you taught all of this already and it's already on here. I don't even need to go to class. And that's what I was trying to avoid. But
There you go.
yes, it's not going to be in the same order, and it doesn't click well when you're watching a 2.5-hour YouTube video of a guy rambling and like talking about math in between every once in a while. So, we're gonna call it good. You guys have a good night. Go home. Go probably directly to sleep. Probably, yeah, definitely directly to sleep.
Eat first.
Huh?
I'm gonna eat first.
I had a peanut butter and jelly sandwich before I came here, and I'm pretty sure that bread is good getting old. What's online for free?
The practice test.
There's some.
There's some actually that came up, like what you taught is online, study.com, but you have to pay how much it is. But there's others that are actually were free. Look for GED practice test or they'll just show up.
So here's a fun thing.
But I've been doing your homework thing, so
Mhm.
you know.
Oh,
I'm doing
the
hours.
essential ed? That thing's so useful.
Yeah, so.
It really is. Like, and the lessons are like stupid short, aren't they?
Yeah, but they're good actually. It
Yeah.
just goes on and just, the practice is actually amazing.
Yeah, they're like 3-minute freaking
Yeah,
lessons.
3 was, but it keeps you going from this class, what you take it. So it continues on, so at least I'll remember.
So here's a couple of things that are in that Google Drive folder that I sent out that nobody's probably looked at.
Can you send it again,
Yeah,
please?
it's gonna be in the one with the YouTube thing.
Okay.
Okay, so notice that I have all these things that don't say class 1 or class 2. So what I have down here, these are actually the formula sheets that they give you when you're taking the tests. This is the HiSET one. And this, these are just things that you're not going to have to memorize. They'll be provided to you. If you're doing like the online thing, I think it'll just pop up on those problems. And if it doesn't, it'll be something you can see. But these are the things that'll be provided to you. There's also, I found this and I thought that was kind of cool. This is a GED reasoning formulas sheet. There's 13 pages of ridiculous amount of crap. I don't know that all of this stuff would be on a GED. I don't think so. My goal for this class is to be able to teach you guys. I want to be able to teach you guys how to use formulas, because you're looking at this and you're like, oh God, that's a lot. That's a lot. I don't know if I can do that. Look at these. These are horrible, right? But if you understand how to use something like this, I could write this out on a sheet of paper in front of you and give you the required information and you'd be able to throw it together. So it's less a problem of memorizing formulas and more being able to understand them. And this thing actually does have neat little explanations on, I think, everything. Like everything. So this could be something that you would print out and have as a reference guide. But I'm going to warn you, you're going to look at this and feel overwhelmed because it's a bunch of stuff that you're not going to see for quite a while. And honestly, all of these will make you dizzy if you don't know what we're talking about. And they're a hell of a lot easier to work. This stuff is a hell of a lot easier on paper than it is looking at the formula. Hell of a lot easier. So don't stress that. But there is also one more thing. Ooh, look at that. Look at that. It's a practice test. 14 pages of problems. And this is the type of problem you will see on GED and HiSET.
What can I find?
That is in the Google Drive and the email that I sent you the other day, because you were not, yeah, there's like a Google Drive folder. If you click on that, it'll go straight to this screen right here. It is not in Canvas. I don't remember how to use Canvas, and I don't remember if I have a login for it.
Where can you find your stuff?
Just go into your email and click on it.
Okay.
Yeah.
Okay.
Yeah, worst case scenario, if you can't figure it out by Thursday, you can just pull out your phone and I'll show you.
Okay.
We're gonna do it that way.
Okay.
But I'm gonna upload all the notes. I'm going to, I wonder if I can put a link into this folder to my YouTube. I don't know. But yeah, that'll all be there. And you'll get through it. I'll get through it. And yes, I see the question, do I volunteer for this and do I like teaching you? I do not volunteer. They do pay me. They do not pay me for any prep time. They pay me for being in this classroom. So in theory, I make 22 an hour. But I didn't get paid for writing any of this. So
You're paying more, huh?
teaching is not a job that you do for money. And people who pay those bills know this, and they will cut costs where they can. Sounds like bad pay? You make more by donating plasma twice a week.
No.
Huh?
You know, that's like,
Yeah, it is
well,
something.
compared to what, 2.5 hours?
It's 5
and
hours
then
of
plus
math
what?
in here.
Yeah,
It's maybe an hour and a half there.
so,
Yeah.
You know, something that I don't understand is when you donate plasma or blood,
Mhm.
they sell it in the actual insurance.
Wait, what was that?
When people donate blood,
Yeah.
people need it in the hospital, they
Yeah.
sell it to the insurance.
Oh, yeah.
oh, yeah.
How is that? You
Oh, the
give it-
entire American healthcare system is a scam.
You get it for free, why they charge?
So always-
Because,
I don't understand that. Making money out of you?
yeah, exactly, because you're getting paid what?
Am I
What
wrong?
did you say?
yeah, well, I mean, when it comes to donating plasma,
That's something I don't
you make like $100 a week. That company is making like $8,000 a bottle.
So they sell it to insurance.
Oh, they make the pharmaceuticals themselves.
Yeah.
They are freaking rich and they are cutting their hours and I'm angry. Yeah,
I donated to children's hospital,
I respect the hell out of that.
that I do, and I don't like needles, I've been doing it
Yeah. I
before,
don't like you.
yeah, since I was young, because of my blood,
Yeah,
Right? You know, you know.
well,
so making it way.
things that shouldn't be for profit, healthcare and prisons. And you know what? Both of them are for profit in America.
Oh, look at the school kids have to pay for lunch, should be free.
It 100%, like if somebody said, hey, do you want your taxes to pay for children's lunches? Yes, And you know what? Pay for their teachers' stuff in their classroom.
Well, how's that? The package you get as politicians, flying off vacations, having their own thing, well, look at that.
Yeah.
All right. Well,
Have a good night, everyone.
Yeah, I need those because I've taken my CompTIA plus M plus, and then after that, I'm taking my Microsoft at least 1, 2, 3. So that's why, you know what I mean?
Yeah.
They have the CompTIA here for practice, but I want to get into my bio major skill.
You got this, man.
Couple friends got this Microsoft one. God have mercy what I added to their.
For the record,
Yeah.
if you finish this class and you take the GED or high set or whatever, and like a year down the line, you have weird math problems to ask somebody, you can send me an email. I am always down to help you guys out.
That's the plan.
Hell yeah. You got this. Yeah. Oh, and for the record, yes, I see the question. What GameStop did I work at? Both of them in Carson, but mostly at the North Carson GameStop. Store 3096-887-0333. Thank you for calling GameStop, where we buy, sell, and trade new and used games. I've said that for so long that will never be out of my head. I am 100% wearing scrubs right now. You can talk out loud, by the way. It's okay. No one's going to bite you. And I'm far more awkward and shy than you will ever be in your entire life. I am wearing scrubs because I had to wear scrubs to work and I was having trouble getting here in time. So I got off work at 4:30. I work 6 miles away and I ride a bicycle. And that was fun. Cool. Anybody need anything else? I'm about to shut this thing off. Okay, cool. If you have any more random weird questions, I'm not opposed. You can email me. I don't care if you send me weird questions in the middle of the night. I get it from my friends. I can get it from my students. Everybody have a wonderful night. I am signing off and going to bed.